is 11-2. We just have two more examples, but before we get to those, I want to talk about conjugates. The term conjugates is the sum and difference of the same two terms. For example, some conjugates would be like the example, or the square root of 5 plus the square root of 2 and the square root of 5 minus the square root of 2. These two expressions would be conjugates of each other because they are the sum and the difference of the same two terms. This is the sum of the square root of 5 and the square root of 2 and the difference of the square root of 5 and the square root of 2. And there's something special about conjugates. Let's look at what the product of two conjugates gives us. So let's find the square root of 5 plus the square root of 2 times the square root of 5 minus the square root of 2. We're going to have to use the rules that we just learned in example 4, so we're going to have to use FOIL. First, outer, inner, and last. So we'll multiply the first times the first, the square root of 5 times the square root of 5. Remember, anytime you multiply a radical times itself, it pops out of the radical. Then the outside terms, the square root of 5 times negative square roots of 2 would be negative square root of 10. Again, that's the square root of 5 times the negative square root of 2. So it's a positive times a negative. That gets us a negative. The square root of 5 times the square root of 2 is the square root of 10. Then our inner and last terms. The square root of 2 times the square root of 5 is positive square root of 10. 2 times 5 is 10. And then finally, last terms, the square root of 2 times the negative square root of 2. The square root of 2 times the negative square root of 2, we get a negative because it's a positive times a negative. And then the square root of 2 times the square root of 2, again, a radical times itself pops out of the radical. Okay, so now we need to simplify. We have negative square root of 10 plus the square root of 10. So what happens to that? A negative and a positive, they cancel. So I'm left with 5 minus 2, which is simply 3. Isn't that neat that you can take something that looks so complicated, like the square root of 5 plus the square root of 2 times the square root of 5 minus the square root of 2, and it simplifies to be one number. And that's what's so great about finding the product of conjugates, is that you can take something complicated, like the square root of 5 plus the square root of 2, and you can turn it into something simple by multiplying the square root of 5 plus the square root of 2 times its conjugate, which is the square root of 5 minus the square root of 2. You may have also noticed that we're multiplying, would relate back to a rule we learned in Chapter 9, A plus B times A minus B. And remember that always worked out to be, when we FOILed it, we always got the difference of two squares. A squared minus B squared. The A times A is A squared minus AB plus AB. That cancels. The middle term always cancels. And then minus B squared. Positive B times negative B minus B squared. So instead of FOILing this, we simply could have followed this rule. We could have said the square root of 5 plus the square root of 2 times the square root of 5 minus the square root of 2 follows that rule. It's the first term squared, so the square root of 5 squared minus the second term squared, the square root of 2 squared. And then remember that square rooting and squaring are opposites of each other. They simply undo each other. Also, the square root of 5 times the square root of 5 is the square root of 25, which is simply 5. So we get 5 minus the square root of 2 squared is 2, which gives us simply 3. So either way you work it, when you multiply two conjugates together, it gets rid of that radical so that you can simplify. So let's look at why we need to know this and how it's going to help us out. Example 5, rationalizing a denominator. So we did this in the last example, or in the last lesson, in 11.1. We're rationalizing a denominator, but this time we're using the conjugate. So remember, we can never, ever, 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 ever have radicals in the denominator, because then the world will explode. Just like we can't divide by 0, we can't ever have radicals in our denominator. So in order to get rid of these radicals, we're going to rationalize our denominator using the conjugate of the denominator. So what's the conjugate of the square root of 7 minus the square root of 3? Well, it's simply the square root of 7 plus the square root of 3. So we simply multiply the numerator and denominator by the conjugate. Remember, as long as we multiply numerator and denominator, we're really multiplying by 1. That way we're not changing anything, we're simply rearranging. and then you just multiply. So I have 8 times the square root of 7 plus the square root of 3, so I have 8 times the square root of 7 plus the square root of 3. Because you can't just do 8 times the square root of 7. It's 8 times this whole expression. So as long as I put parentheses around it, I'm saying I'm multiplying 8 times the whole expression. And you could distribute it out, but let's wait and see if we need to do that at the end. And then we have these two conjugates. Remember that when you multiply them together, the square root of 7 minus the square root of 3 times, and I didn't mean to put that, let's get rid of this. Square root of 7 times, or minus the square root of 3 times the square root of 7 plus the square root of 3. Remember that since these are the difference of and the sum of the same two terms, that it always boils out to be the first term squared minus the second term squared. And if we simply use that rule, we have 7 minus 3, which gives us 4. So that's what we're going to do down here. I'm simply going to write the square root of 7 times the square root of 7. So I have 7 minus 3 on the bottom. And then we'll simplify. So I have 8 times the square root of 7 plus the square root of 3 divided by 7 minus 3 is 4. Now we always want to check and see if we can simplify. It's a good thing we didn't distribute, because then we'd have to do more simplifying than just having 8 on the outside. So we can simplify 8 divided by 4, which is just 2. So I get 2 times the quantity, the square root of 7, plus the square root of 3. And you can leave it like that since there's nothing else we can really do with it. You can either leave it like that, or you can FOIL it out. So we'll go ahead and FOIL it, or sorry, not FOIL, but just distribute. 2 times the square root of 7 is 2 square roots of 7, and then 2 times the square root of 3 is 2 square roots of 3. Since these are not like radicands and we can't simplify inside the radical, it's in simplest form, and we are finished. I know this is kind of a new concept, so let's go ahead and do a couple more. Same thing. So we want to simplify. We got to get rid of these radicals in the denominator. And to do that, we're simply going to multiply by the conjugate. So the conjugate of square root of 7 plus square root of 5 is the square root of 7 minus the square root of 5 over the square root of 7 minus the square root of 5. So we just have 4 times the square root of 7 minus the square root of 5. Make sure you have those parentheses there. It makes a huge difference. Divided by, now remember, when you multiply the conjugates together, the square root of 7 plus the square root of 5 times the square root of 7 minus the square root of 5, basically you're popping your numbers out of their radicals and you're finding the difference, so 7 minus 5. So when we simplify, we have 4 times the square root of 7 minus the square root of 5, divided by 7 minus 5 is 2. And again, we can simplify. 4 divided by 2 is 2. So I have 2 times the square root of 7 minus the square root of 5. And our last step is simply to distribute. So I have 2 times the square root of 7, 2 square roots of 7. 2 times negative square root of 5 is the negative 2 square root of 5. Cannot combine these terms. They are not like terms, the square root of 7 and the square root of 5. So there's your answer. We're going to do the same thing on B. First, you have to think, what's the conjugate? Square root of 10 plus the square root of 8. The conjugate of that would be the square root of 10 minus the square root of 8 divided by the square root of 10 minus the square root of 8. That way, again, we're just multiplying by 1. If you divide these, you get 1. And then we want to multiply across. So I have negative 4 times the square root of 10 minus the square root of 8 divided by, again, when you multiply these, you just end up subtracting. So I have 10 minus 8. Let me simplify. Negative 4 times the square root of 10 minus the square root of 8 divided by 10 minus 8 is 2. Negative 4 divided by 2 is negative 2. I'm going to start back over here. Negative 2 times the square root of 10 minus the square root of 8. And then here there are a couple different things you can do. So what I noticed about this problem on B is that the square root of 8 is 4 times 2. I can definitely simplify this. So you can either do that now and then distribute, or you can distribute and then simplify it. I'm going to distribute first. Negative 2 times the square root of 10 is negative 2 square roots of 10. Negative 2 times negative square root of 8 is plus 2 square roots of 8. Now with 10 is simply 2 times 5. So there's nothing I can take the square root of for 10. It's not a perfect square. There are no parts of it are perfect squares. I can't simplify the square root of 10, so I'm going to leave that first part alone. So I have negative 2 square roots of 10 plus 2 square roots of, but 8 is 4 times 2, and I can take the square root of 4. So I have negative 2 square roots of 10 plus 2 times, bring out the square root of 4 is 2, and then leave the square root of 2 inside. So I have negative 2 square roots of 10 plus 2 times 2 is 4 square roots of 2. Okay, I know that was a lot of steps, but remember, your whole goal is to, 1, make sure there are no radicals in your denominator, and 2, make sure that your answer is in simplest radical form. That means as much as you can pull out of the radical, you want to pull out of the radical. As many things as you can combine together, you want to combine together. So we had to simplify the square root of 8 since we could pull some out of that. We don't want to leave all those numbers under the radical. Let's look at one more like that. So again, got to get those radicals out of the denominator. To do that, multiply numerator and denominator by the conjugate of your denominator. This, again, is called rationalizing the denominator. Right now, this is an irrational number. That's why we call it rationalizing the denominator, because we're going to turn this irrational denominator into a rational denominator by multiplying by the conjugate. So then we just multiply across negative 5 times the square root of 11 plus the square root of 3, divided by, and then when you FOIL these out, you'll always end up with these numbers pop out of the radicals, and you find the difference of them, 11 minus 3. So then I have negative 5 times the square root of 11 plus the square root of 3, divided by 11 minus 3, which is 8. Now in this case, 11 is a prime number, 3 is a prime number. There's nothing I can pull out of these radicals. Also, negative 5, 8, you can't simplify. So all I'm going to do is, well, first, let me just go ahead and I'll distribute first. So I have negative 5 times the square root of 11 is negative 5 square roots of 11. Then negative 5 times 3, or the square root of 3, is negative 5 square roots of 3. And all of that is divided by 8. And since the whole thing is being divided by 8, I can split it up into negative 5 8 times the square root of 11 minus 5 8 times the square root of 3. So all I really did is, since the whole thing's divided by 8, I just split it up. Negative 5 8 square roots of 11 minus 5 8 square roots of 3. And that's your answer. All right, we're running out of time on this video, so we will do the last example in the next video.